Okay, welcome back again. In this session, what we will be covering is the following topics. Between 6 to 7, let us cover this. Then 8 to 10, we'll get into class and instant attributes, methods, all those things. Okay, so I will not cover everything today. I don't think it is possible, but we'll try to do some initial introduction to class and objects. It's a very large topic, and Python being an object-oriented programming language, lot many features are there. So I plan to cover maybe part of it before the midterm, and the rest of it, the nuances of what all we can do with the objects and classes after the midterm. Okay, that before we start off, the basic things which you might have already studied, I thought I'll give just a brush up of that. Programming languages can be classified as two types: static and dynamic typing languages. I'm sure you know C and Python, they fall under what categories? Anybody wants to try it, or shall I go ahead and show you? It's okay even if it is wrong. I'm not going to say anything. Okay. C is static, right? Okay. Okay, who is on the line? Who spoke? Sorry? Swati. Okay, thank you. Thank you, Swati. So you are right. Static and dynamic typing. A language is statically typed if the type of variable is known at compile time. So the difference here is on the whether the compiler, which is looking at your variables, does it know what type of object or a data type a particular label is referring to or a variable is referring to. So now you may wonder what is the advantage of that. At least in C, suppose if you have a variable int I and then you have a float f. Now the C compiler knows wherever I am referring to, I is an integer and f is a float. Now all of you know that in the CPU, now I am talking about Intel CPU, we have a floating point processor also, FPU. But the embedded processors may do the floating point operations also in integers, using the integer ALUs. They perform the floating point arithmetic by using some floating point libraries, which help in doing the floating point arithmetic using some integer data structures. Okay. Now, in case we are thinking that most of the high-end CPUs, we have floating point processor as a co-processor, which is also along with the CPU, they are there. Now, the CPU registers may be 32-bit or 64-bit, and FPU could be 80-bit, or it could be even 64-bit, or even 32, okay, or even 16. We have a floating point which is half resolution, wherein we know that in machine learning languages, if you want to port your machine language, model onto embedded processors, we will be using a reduced the floating point numbers which are just 16-bit wide. Okay, they are called half resolution, or I forget the name. This will be for embedded applications wherein you want to save memory and then operations also to be faster. And of course, when you have a floating point number which is 32-bit wide and then 64-bit wide and then 16-bit wide, the ranges of the values are also less, and the resolution with which what they can represent also comes down. But still, it is a floating point value which occupies only 16-bit. So why am I saying all this? Because when a variable is an integer type or a floating point type, then the C compiler can associate these variables or bring the variables from the memory, because you know that when you declare, they are all in memories, and when they need to be operated upon, they need to come into the processor. So they can bring into the relevant registers. Okay, integers will be brought here, and floating point register thing could be brought into a floating point registers, and they will be operated upon. So that's why compiler knowing the type of the variable helps in terms of generating the instructions which are optimal, and it occupies less space, and it consumes less power, and you get better performance. So that's the advantages of a language which is static typing. So when the variables are declared, they are tied to a particular type, and you need to, until the variable is goes out of scope, they will be of the type. Okay. Whereas in Python, we know, okay, let me complete this. So the big benefit of static type checking is that it allows many type errors, okay, to be caught early in the development cycle. That is, during the compilation itself, many of the problems could be solved. Suppose if you are bringing a floating point value into integer, there is going to be a mismatch in the format. So unless you forcibly do something, typecast it, it is going to be raised as an error, and maybe human mistake that it could be resolved. So static typing usually results in compiled code that executes more quickly. That's what I meant by giving you some example of why it is more efficient when you have a static typing languages like C, which performs better than in terms of execution time and memory, compared to languages like Python, which is a dynamic typing language. Because when the compiler knows the exact data type that are in use, it can produce optimized machine code. When I say machine code, it's a assembly instructions of the CPU on which this C program is going to be running on. In contrast to static type checking, dynamic type checking may cause a program to fail at runtime. So because during the compile time, or the interpreter may not be clearly aware of what type of object is being referred by an identifier, and it could get into some trouble. It's not always. I'm not saying that Python is full of bugs, or it could lead to some runtime errors always, but still, majority of the things will be caught by the interpreter, but something could be missed out, and which will be caught only during the runtime. So especially when you are passing a parameter, and different objects are coming into the functions, the type is not there. We when you know that when we define a function, we just say function name and the parameter. So especially if it is a at least keyword parameter, we at least assign some value so we can get to know about the type. But if you are passing just an identifier, it could be anything. It could be carrying any object that it is coming in. That's why when we did some assignments, we wanted to check whether the object which is coming in is a function object, so that we can call that object with some parameters or without parameter, how many parameters. So that's what we checked it, because we need to do a checking inside, because there is no type associated with that. In case if it was a C, suppose, okay, first of all, you couldn't have done that kind of an assignment with one single object coming in. I'm not saying it cannot be done. I'll tell you how it can be done. In C, in Python, we got an object which is a function object, maybe pointing to a single parameter or a double parameter. It could be even n number of parameters. So we checked it with F1, F1, and then we did the processing. Now, how we could have done the same thing in a C language? I said that it is very strongly typed, so I cannot pass a function object. We can pass function pointers. I'm sure it is similar to a function object, but how can I pass different function pointers into a same function which accepts only one variable? So we could do that. We could say void star, okay, which can be made to point to any type, including a function pointer. And then we need to, like what we did comparing F1 to F1, we need to compare it with the relevant function pointer inside. After typecasting the void star to the relevant pointer, and then perform the test, and then do the same thing that we did. So it will be a good exercise to think about how we could have done the same function implemented in C. Still, it allows you, though both are different type of languages. One is strongly typed, one is static type and dynamic typing languages. We can perform the same job, but in a different ways. Okay, there we do a typecast to say that, for a moment, assume that this void star is as a function pointer, and it is of type accepting two integers, returning one integer. So all that we need to say when you are defining a function pointer in C. Whereas here, just build a function and then pass it across. So there is no type associated with the object which is coming in. But when it is being accessed, it is going to check the function, and then it is going to verify whether you are calling the function object with relevant parameters or not. If you do so, then it is going to throw up an error, runtime error, that this function object expects two parameters, but you passed only one parameter. So that could be caught only at the runtime. But we did a defensive programming by comparing it with fn1 and fn2, verifying that it's actually a function object which is accepting two parameter or one parameter, and then we pass the parameter. So we actually took care of that in the assignment, so that the runtime errors don't come up. Otherwise, we could have landed into that trouble. Okay, so example programming languages. Static typing is these languages. I'm not sure how many of this you know. At least I know I have written Pascal program, Fortran in my college. I learned, that's the first language I learned. C++ I know, C# not much, Ada no, Java and C. Okay, so I want to learn Haskell. I think if you guys are very fond of programming languages, I suggest you learn Haskell. Okay, now dynamic typing language. We know, all of us know Python, I'm sure. So we can, I'm sure you know the difference between this. Okay, that is the typing, okay, based on the data type. Now what about the association with the label and the type? Okay, so programming languages can also be classified as either strongly or weakly typed. Okay, that typing is different, static and dynamic typing. This is strongly or weakly typed. Now, do you want to go ahead? Anybody want to say which is falling under what category? Nobody? Okay. This is strongly typed. This is weakly. Okay, it is not. Okay, weakly. Okay. It's weakly. Okay. I'm not sure. You're right. So it's the other way around. Okay. C is weakly typed and Python is strongly typed. Now I am contradicting it. I said dynamic typing and static typing, don't mix it with that and this. Now let us see what I mean by a C language which is weakly typed. Okay, suddenly I said that you cannot assign anything, but the issue I will tell you now. Before even I go into that, I will tell you what all we can do with C. Okay. Now suppose I have an integer. Okay, integer with a hexadecimal number. Okay, A B C D. Okay, I will tell you. They say dead beef. I don't know anyone of you. Beef is spelling is correct. Okay, a non-vegetarian or vegetarian. I am a vegetarian, but I'm writing this because this is a standard used for representing some hexadecimal value. You can see that all of them are valid hexadecimal number. So suppose if you have an integer stored here, okay. Now I can get the pointer to this, okay, in star IP equal to ampersand this I, suppose this is I get the pointer. Now I can make it character CP equal to char star IP. Okay, it allows me to change the IP integer pointer to a character pointer, and then I can assign character C1 equal to star CP. No issues. Now what will come into this based on we saw that based on the little endian or big endian, either BE will come or EF will come into C1, hexadecimal value of that. So it allows us to look into the implementation of, or the representation, moreover the implementation, a representation of an object. Okay, as far as C is concerned, I is an object, data type or a variable, and I am going into that deep into it, and how is it stored in the memory. I am able to get it. I am able to get the address where it is stored, and I am able to access them in a totally different way than it is supposed to have been. I am accessing it as a character, and nobody stops me even say that floating point star fp equal to floating point, sorry, a very very bad character handwriting. So fp is equal to float star again ip. Now again I can access this whole thing as a floating point number, and which I will get something wrong. So some value, but it could be a valid value or a invalid number also, because based on the pattern. So this is what actually categorize the C language as weakly typed. Okay, it allows you to move across, like white star. I said white star. It allows you to move any pointer as a white star and then convert that white star into any type of the pointer, even the floating point, sorry, function pointer or an integer pointer or anything. So mostly sometimes these kind of things when you do, C language gives it to you that you have to handle it in a careful way. Otherwise, I am not responsible. Whatever you get out of this kind of a erroneous handling of this, it's your problem. Okay, so this is why it's called a weakly typed language. Now, why is it not a Python a weakly typed language? Because the first thing is it doesn't even allow you to, even though it allows you to get the ID, you can't do anything with the ID. You can't say star ID and write into something, right? It will not allow you to do anything. Okay, maybe you can get the ID to know that maybe the object what I am looking at is a different object or something, no, same. Okay, is it referring to the same object or different object? But I cannot do anything with that ID. So it has to be done using a proper, well-defined programming language syntax. It is syntactically correct statements. I can access it. I can do something, and I cannot change the type. Here also you can do a typecasting. I'm not saying that it's not possible, but there is a difference here, wherein every object you said that I said that even if I equal to 2, it's a separate object and it's assigned to I. When you are changing it, it becomes a new object, and you are not actually changing that object. It becomes a new another object 2.0. Then you are assigning it to a variable. So you are not manipulating the same object in a different way just by cheating the language. Okay, using the syntactically allowed features of the language. Okay, so that's why Python categorized to be a strongly typed language, whereas C is a weakly typed language. So do not get confused with static typing and dynamic typing. Okay, that's typing is different and the typed language is different. Now let us look at some more definitions. A strongly typed language does not allow to use one type as another. Okay, C allows any pointer type to be converted to any other pointer type simply by casting it. C allows the programmer to access the underlying representation of data types, as I explained. Sample C code, floating pointer f int I equal to 4, I can change it to fp and star fp equal to f. I will get something, but its compiler will go through, no issues. It will not give you a warning. It will zero error, zero warning you will get for this code, though you are doing illegal things or incorrect things, because you are changing the value 4 as a float, which is not going to be 4.0. Okay, please don't think that if I do this I will get fp star fp as 4.0. Never. No, you will not get it, because that 4.0 representation is totally different from what you represent as 4. Okay, in sorry, not this, I should say 100. Okay, so you will not get anything other closer to what you defined as integer float. So integer to float promotion. Okay, another major thing here, C does it. Okay, it does it blindly. Okay, it doesn't even ask you to verify or ask you whether it is okay or not. Now float f is equal to 2. Okay, I think it allows. You don't need to do a typecast here. Okay, float to from integer to float, because this is called a promotion, integer promotion, or promotion to the higher representation, because certainly you can represent 2 very well here in floating point and much more in the range of 2. So it allows without any problem that you can assign an integer and to a floating point variable, and quietly it takes it, and even you can pass across the parameters. And even if you do some operations like 2 plus 2.0, then it is promoted to float, and then the job is done. So this is also there. I will tell you in Python also it does something. Some part of this also is being done there, but object assignment you cannot do. Okay, you cannot convert suddenly an integer object as a floating point object. Integer object will remain as an integer object. Floating object will be a different object, and the label could be pointing to the floating point object. Okay, that they are different. Okay, in Python. So Python is strongly typed as the interpreter keeps track of all the variable types. You know, even though you are not keeping track of it as a label, interpreter internally maintains that uh, when you are assigning them some values or objects. Note that static and dynamic typing and strongly and weakly typed are two totally different concepts. Example programming languages: strongly typed Python, Java, C Sharp, Lisp, Haskell, and then weakly typed are this, they fall under this. Okay. So any questions? Anything before we go? Okay. So this is the how different languages fall under different categories. So you can see that both are static and weak. Not too many companions for these two guys. There are many other guys having some friends around, and they happen to be the first, and they still are alive and going strong. C and C sharp. I'm sorry, C plus plus. Okay, now this is the logical part to go into operator precedence. Okay, I'm sure all of you are aware of it. I thought I will just give some brief introduction to this in this session. And this is may look similar to C, but you can see that this guy is there, lambda. So it is not operators of C. It is for Python. And any guesses which has a higher precedence, or which has a lower precedence? So maybe you can just look at different things inside, then you can make out whether this is low or high precedence, or this is what is at the top is a low or high precedence. Then things will be like that. So any guesses? Anybody wants to go for it? Which is lower precedent and which is higher precedence? Sorry, 18 is high. Okay, of course. Then this is low. Okay. Anyone else? Anybody wants to contradict him, or all of you agree with him, or you don't have any opinion? Okay, let me give a clue. Okay, this at least we know in C, which is higher precedence and lower precedence. Okay, good. So I'm not confusing you. You are right. So low and high, because you know that this is high. Okay, at least I think I don't know any of I don't know who answered it. Can you tell me who answered? Sorry. Ah, wins. Okay, okay. So I think this would have given a clue, if not the rest of the things. And good. So let us now look at some interesting stuff on this. Okay, one thing I want to highlight here is all the operators, if you see, they are all looked at from left to right. Okay, by whom? By the compiler, because you know that Python also has a compiler, and except this guy. Okay, the exponentiation operator. Except this, everything is left to right. Okay, now let us. I'm going to show some example code. Okay, to do this. Boolean operators. Okay, we will cover this also. And before we go there, we don't need to come to the PPT. I'm sure all of you know that when you have in C like this is of course left to right. Here also left to right operator. Now when it you know that if it is lazy computation, when it encounters that something is uh, calculated to be false, computed to be false, then the rest of it will not be computed. Okay, if you put any side effect parameters here, suppose p plus plus or I plus plus here, if you write, then this will not be computed based on this value. Okay, you are not supposed to have any operations which has side effects in this kind of a thing, because if it is computed to be false, it will not compute anywhere, because the total result is going to be anyway false. So it will stop with this if it happens to be the first one, or even this happens to be false. If this is true and this is false, then it will not compute this. So that's the same thing here also is done by our friend Python. But only thing is we saw that and or not is what is used. They don't use operators here. The here okay, but Boolean operations, we'll say, we'll see about other things later. And not is not this one here, it is used here, but you know that this is being used. But not is no, we use this also. Okay, and this is very obvious, so I don't want to explain this. One thing let me tell about OR operator. The OR operator returns the first true value or the last value if nothing is true. That means what? OR operator does the reverse of what the AND operator does. If this is false, then only it will compute the remaining one. If this happens to be true, then it will stop. Then, so if it everything is false, then it returns the last value, whatever is computed here. Or if a true value is found in between, then it computes that. Okay. Again, you know that this is going from left to right, so there is no confusion there. Similarly, and I told you that it will stop when the first false is found or first false is returned. Okay, otherwise they all evaluate to true. The last argument is returned. If everything evaluates to true, the last argument is returned. Okay, so this is enough. All of you are already familiar with this, so I don't need to explain it. So let us now look at quickly how much time we have. 30 minutes, right? Okay, so let us look at some code. Okay, I am going to steal from here to be okay. Okay, no, sorry, I should not have shown it. Okay, no problem. What do you think will be the value here? Okay, I think it will be time consuming to ask you. See, plus is left to right, it goes, but when it encounters this, it's right to left. So this is operated. This is two are grouped, and these two are grouped. Now, what is the priority of this? This is a higher priority. We saw that it was in the top compared to plus and minus. So I can, of course, undo that. So this is what is going to be the value. Okay, so it's not a very difficult thing. Okay, 3 to the power 2, 9 plus 2 minus 3. Okay, now I will quickly go through it. I will see when I have to ask you. Okay, something I think it will be better to I type it rather than asking it, because it will make you think. Anyway, this I will leave it. Okay. Now, what is the computed value here? Again, division. If you let me keep that operator here, division is higher precedence than this. We know that. So this will be grouped as I shown here, but this happens to be a floating point division. So one of the result happens to be a floating point, the rest of it will be floating point. So the result will be not 0. If maybe some of you might have guessed it as 0, but it is 0.0. Okay, so now let me type some values rather than printing it, copying it from there, because it is easy to guess it. So now let me say num3 equal to, please tell me the value I'm sure all of you can type it there and then get the value, but I'm believing that you will not do that. Okay, any guesses? Any value? What is that going to be? I'm sorry, I should show you. Okay, I'm not getting any answers. So now how is it going to be grouped? It is left to right. So this will be performed first. Then on that, this will be performed. Then this. After that, the rest of it. So let me now steal from here. I'm sure you can see the remaining in the bottom also. So there is no surprise here. Okay. So this is how this will be expanded, and you will have this again. Yeah, I forgot to say that this will be grouped together, and then you will get the value. So I'm not going to explain anymore. If no doubts are coming, I am sure all of you are aware of it. So I don't want to bore you with what you know already. So let me quickly go through that so that at least for a practical, it will be remaining as an exercise for us. Remain there. See here, I am doing an integer division, and it also does it from left to right, grouping this, and then perform this division first, and then use that number to do this. So when it encounters this and into multiplication, it will group this, and this is what will be the grouping finally. Okay, so I'm sure you can compute it. Okay, not a problem. So num4 is done. Now num5. What am I doing? I think it is not too much of surprise here. Why did I bring it? Okay, multiplication by having a higher precedence. So that's a very well-known fact in our BE. Fine. Now let me talk about this. This is a little bit of some funny behavior you might encounter. See here, this is very obvious. It's a floating point division. See, what happens is if it is a floating point division, it has to perform a floating point arithmetic. Okay, so it will do automatic promotion. What I mentioned in C, the same thing happens in this language. But only difference here is this value, whatever this object 4 and 2 were, they are not disturbed. Okay, they remain as 4 and 2 only. But the computation happens in a floating point value, and that is what is returned. These objects remain as same. Okay, there are no impact of that. Now here also it will perform the floating point division, and you will get a 1.5 here. But what happens here? Okay, this is very obvious. Okay, floating point number you are given and floating point division you are given. So this is also not a surprise. So let me bring another surprise element, maybe here only or somewhere else. I think down I am bringing it. Okay, no problem. Let me one by one, let me go through it. Now what is happening? 10 into 2, very clear. This is first done, and then this is performed. Now this is little, yeah, funny here. What happens when you have two operators? So this is grouped as a unary operator. Okay, and this is also, this can be 2 minus 5. Now when this is has to be done, it will do plus as a unary operator. So it performs this. Okay, and it does the division. Okay, so this becomes a 2, and then the division happens, which is a floating point division. That's why you get finally a floating point value. So I hope this is clear. For clarity, I have put it there in the top. You will be able to verify in case if you are not following now. At least it will remain as a record. Later on you can find out. Now what about this guy? Similar thing. I think I have same thing. I have printed it here to show you num6 again computed here. Okay, now what about this? There is here again, yeah, minus and plus is being covered together. We have these two. Okay, this is 2, or I'm actually perfect. I'm in case if you want to change the order, I'm doing that. You need to specifically mention the parenthesis. because parenthesis happens to be the highest precedence here. So what is inside of that is computed first. Okay, so that way your parenthesis helps you in terms of grouping the way you want the operations to be performed. Okay, so this is a floor operation which I thought I will highlight it to you. Now this is what I was mentioning it. What is this? This is an integer operation, okay, integer division. And if you have both the integer operands, then it performs an integer arithmetic. But when you give integer division, but you are given a floating point number, then it assumes that you want a floating point arithmetic and it performs a floating point division. It doesn't do integer division anymore. Even though you have mentioned it as integer division, it performs. This is all some behavior of the language which I want to highlight so that you should know what happens when I mix up operator and the operands of type. Because this is an integer division operation, whereas operand are one is integer and one is floating point, then what is performed is a floating point arithmetic here. Okay, whereas here it will be an integer arithmetic. Okay, so I wanted to bring that up. That's why I gave that example. Now, I don't know whether I'm going fast. Please stop me in case I am. I think it is the same thing, integer division and floating point division, even with the integer operator. Okay, so same thing I am explaining it. Now, Boolean operations. So, if you mix up a Boolean operation, again, our precedence comes. Okay, let us see what is the where is our comparison. All this left to right, but they are all below. Okay, compared to other arithmetic. So this is done later compared to all the arithmetic operations. So when you have this, this is the low precedence. So this grouping is done this way. Okay, if you pass this, what you will be doing is this will be done first because this is the highest priority precedence and this is higher precedence, and then the rest of it is done. So both sides are computed and then this comparison is performed. Okay, so you know that based on the precedence it goes and everything is left to right, so there is no confusion. And the value what it returns is a Boolean operation because this is a Boolean comparison of these two numbers which happens to be 2 less than 5. So it gives you true as a value. Okay, fine. Now I think same thing I am giving it as a proof that x and y are computed. These values are there and then nothing much. Okay, I just thought I'll show you this 2,5 because this will be integer division and it will result into 0 and this will be 1, so it's very obvious. Now let us do something interesting using Boolean operators and or look at this. Okay, now always in a Boolean logic when you write, we always associate the not immediately to the right of the what is this called, operator. So this is group and then why is it so? Let us see. Not operator, where is it? Not is above, then and or. So association of not is done first and then the and or are done. So it groups these two together first. Wherever not is there, that is, they are grouped together. So first they are computed and then the rest of it in the order. Now and or, and first performed and then or is performed. So when you have and, they are grouped before or is grouped. That's why we see that the parenthesis is around this and operator and then the or is left untouched. After the whole, this and is also grouped, computed, then only the or is done. So because or happens to be the least among all the three operators, so the grouping of things happen first not first and then the and then or. And while doing it, it will do from left to right because they're all the interpreter or the compiler goes through it in the left to right order. Okay, so what you get is very obvious result. I hope this is clear. Okay, now let us do this. Hmm. Okay, this is same thing. I am showing it in a grouping as per the precedence, and then if I want to do it, if I have it like this, and first this is grouped, and then this is grouped. Okay, that's why you see that this is grouped first, and then this grouping happens, because left to right, first this and is encountered or is ignored when it sees first, so that you know what to expect here. What happens here? Not is grouped, then okay. I have put a grouping myself, so there is no fun about it. There is no fun. Only thing is this not will be associated with the whole thing. Okay, this not okay to the right. Okay, that's result. I'm not verifying it because it's very obvious. In case if you are very fast, you can find out, or if you are looking at the code later, it will be very obvious. So I am not showing you, except the grouping. There is nothing much to do. Now one more thing here. Bool is it will return a boolean type, and any string or I think I mentioned it sometime back. I'm not sure. Any empty string is evaluated as a false. Empty list or bar or thing. I think I mentioned it. Okay. So they're all none is what? None. Do you think none will be false or true? Any guesses? Okay. Yeah, true. Very good. I'm sorry. You said true, is it? For none? Okay. None is yeah, yeah. It's a little bit of, maybe you may think that it's a known type, none type, so it has to return a true. But that's yeah. But see here, none means it's of no type. Is not belonging to any type, so it returns a false. Okay, that's nothing. Nothing is there. It's there is nothing inside. It doesn't refer to any type. So it returns false. That's a language feature. Okay, so sometimes we may be fooled by these kind of questions. Uh, why I am telling all this, because there are something which are likely to be confusing us, and mostly these interviewers will be trying to catch you on this only. I don't believe in that, but some people have fun in seeing whether you know this or not. Okay, I don't mind if you don't know. This is very how much time does it take for us to type this and find out? But some interviews people form opinion of based on this. So better you know this. Okay, we normally think that none is a valid type. Okay, some type which is language defines it, so it should have returned true. But the counterpoint is none refers to no other valid type. It's not assigned to any type. It's like malloc returning a null is not having any memory. So it's equivalent to a false. So you can treat it like a false, and I can convince why Python language decided to call this as a false. And I'm here to uh, convince you what language does. So that's why it is false. Okay, good. Okay, sometimes we make mistakes. We assume that language behaves in a different way, some ways. Now you see here, this is also a little funny. Plus 0, minus 0, we are giving some value to it, and then you know that floating point can take a value which is a positive 0 or a negative 0. So why not give it true? Okay, but unfortunately you can debate it, but it returns you false, because any zero value doesn't matter whether it's a positive 0 or negative 0. It's a 0 is 0. So though floating point, do you know why floating point has this representation for plus 0 and minus 0? Because they have decided a sign bit for float. Okay, see, there's a very funny reason for this. Why did float allow a plus 0 and then minus 0? Because floating point has this sign bit okay, which is reserved for a sign which can be 0 or 1. If it is 1, it is negative, and this is positive. And they said that all of them 0 means it's a 0. So once they decided this, they cannot give you anything else other than this is zero point 0, and this can be a, if you keep it like this, plus zero point 0 and minus zero point 0. Now I'll tell you one more reason why this is also useful, not only because the representation allows you to give these two values, but suppose in a DSP, especially in a digital signal processing or image processing, you are doing some floating point arithmetic, okay, keep on reducing some value, okay, maybe some floating point value, a float minus minus you are doing or something, you keep on reducing it. Now, based on this value earlier, whether it is having a big positive value or a big negative value, okay, big negative, you keep reducing it. Now, what happens in the range? 0 point 0 is there, minus infinity, plus infinity. You come from here or you may come from here, right? When you are keep on reducing it, the number could be coming from the positive side of the real axis or a negative side of the real axis. So it might land up here as a 0 point minus 0 point 0 or plus 0 point 0. So allowing this representation for giving you these two values helps you in finding out whether the value was earlier big, very low negative value. Okay, I cannot say that big negative value, a very low negative value, or it was a very big positive value, based on whether you are getting a plus 0 or minus 0. Okay, so that's the advantage of having this representation in floating point, and it is being used in the signal processing also. So that's another use. Okay, apart from explanation that floating point gives you this kind of a representation, but why integer doesn't have that? Because you know that integer is a 2's complement, okay, not minus 2 complement, 2's complement, and you have only one representation for 0. Okay, if the sign bit is 1, it is always a negative value. Okay, if there is no minus 0 here, okay, there is all sign bit with 0, or the top portion is remaining. Okay, they all happen to be all positive value, and then the negative values will be with the MSB 1, with even 1000 is a most negative, which I say minus 8 when we have a 8-bit number. 100, okay, binary pattern I'm telling, 000 represents, okay, it's not a 4-bit value, okay, minus 8. So is minus 127. Okay, so that's why you have a negative number which is 127 when positive is 126 and 0 is gone here. So we have, there is no place we can represent a negative 0 in an integer. So there is nothing called negative 0 in integer. So that's maybe if someone asks you in any interview that why is there nothing like minus 0 there, where there minus 0 point 0 is there, you can logically explain them. Okay, so now let us see what are some more things before we close. I said empty string, both strings are okay. Empty set, empty list, empty dictionary, all of them result into Boolean false. Okay, if you convert it, now what are you doing actually here? You are converting this. This is a string object. It's a set object. Already object is created with no value, no element, and then we are converting into a Boolean object. Now, why did I say that this is a very strongly typed? Sorry, what did I say? I forgot what did I say. Second one we said, right? Yeah, sorry, strongly typed only I mentioned it, right? Why did I say strongly typed? Because it doesn't actually make this object, empty set object, as a Boolean object. Okay, it actually a kind of a constructor. It creates a new object, Boolean object, accepting a set object as an input, and gives you a new object here. It's not changing this object anymore. It is creating a new object for you. So though here we are also doing a similar to typecasting, it is not a typecasting. Okay, we are creating a new object, whereas in C we do a different thing here. When I say floating point star fp is equal to ampersand some float value, okay, now CP, when I say character CP is equal to character star FP, this pointer which is pointing here is changed now. Okay, it is now corresponding to, we are not creating a new object or something. The existing object itself, the address we are treating as a character pointer now. So typecasting here is a different connotation, and we cannot call this as a typecasting. Here we are creating a new object with an input object. So we are not changing the existing object into a new object. We are creating a new object as a input. We are taking a different object. So there is some transformation happening here, and that's why I'm saying that it is strongly typed. It doesn't change the existing type to something else. Python is very strong in that. Okay, I hope this explanation is clear. Now let me just put it in a loop and then show you. Okay, now what happens? What is this? What is it going to return? Bool of 1. 1 is an integer object and it's a non-zero value, so I expect it to be a true. Okay, but if it was a 0, it will be a false. Okay, so it depends on the value that you are having and not the type of the value. Even 0.0 is returns a boolean false. Okay, that's how this handles. Okay, this you should know how actually the Python treats different data types here. Okay, here also again this object is not touched, a new object is created. Okay, now what is this? I am just printing everything. So what did I do? I pass the set. Okay, this is a set. I pass one by one to value, or okay, it's a generator kind of a thing. Set is giving you one value at a time, and then I'm just saying if value. Now when you do if value, if is actually conditional operation which checks the boolean value only. It cannot do on any of those objects. So it internally does a conversion of a boolean operation. Okay, it converts this value, whatever you pass different objects, into a boolean object and then checks it for the true or a false value. Okay, so it is internally done here. Okay, maybe there's some optimization will be there. I don't think they will perform really object creation and then do it. Okay, then it will be very slow. Okay, already Python has a very negative connotation that it is very slow than a C language or any other language. So when the interpreter does it, actually it will be doing in a different way. Okay, I'm not saying that it will create a boolean object and then does it, but what you need to accept or understand it here from a language perspective is this value, whatever may be the type of the value, is not changed and it is made into a boolean object or a boolean content and then verified whether it is true or false. Based on that, it takes path and then prints you that. Okay, so that's what you get it. Okay, so internally how you have to interpret it is different from what actually the compiler is doing. Most of the things what we think compiler does will be totally different from what you think. Okay, so don't get fooled. Okay, now what is happening? True and a and 0 and true. What do you expect to have? Okay, what do you expect to get a print here? It is going to print the value 0 because it is going to do a left to right, and then it stops when it encounters a false value, but it returns the object. Okay, it returns the not the boolean value, it returns the object of what it encountered here. If it was 0.0, it will return 0.0. If it is 0, it will return a 0. So let me say that. Before I say, let me write it like this. So here, what is returning? It is not returning any boolean object here. So that's a really funny thing. When it does it, it's actually do a boolean operation. Okay, but when it returns it, it returns the object of this. Okay, this object itself. Okay, it doesn't return the boolean result. Okay, here that's the behavior of this AND operator. Okay, so that's why you see here it returns the float operator. Okay, maybe if you want to okay, I don't think I need to type a type. You know that if it is printing 0.0, it's a floating type. Okay, you can believe me. Now what happens here? It returns a list object. It returns a list object which happens to be a empty list. That's all. Okay, so this is little not very obvious from the way it looks. We may think that it is returning a boolean, but it is not. Okay, so maybe we may make a mistake and runtime error we may get, and we'll get into confusion. That's why I'm highlighting all this intricate loopholes of, not a loopholes, intricate behavior of the language. Okay, I don't call it as a loophole. It's a well-defined behavior of the language. So now what is happening? A equal to true, B equal to true. We are assigning it. Okay, that means this is a boolean type objects. Okay, they are boolean type because you are writing a boolean value. So the type of this A will be bool. So this will perform a boolean operation. So there is no boolean conversion. It will return a bool value. So what you get will be, why is not coming? Oh, I'm not printing it. Okay. So I need to print it. So let me print it. So what do you expect? Here I am getting a string because CA has been assigned. So this has evaluated to be a true because both are true, and operator. Okay. Then of course value 1 you will get. Okay, it's very obvious. Okay, so we have come to the end of this session today. Not today, sorry. You don't run away. Come back at 8 o'clock. Okay, what do you expect here? A and B. A happens to be both Boolean, so this will be performed. It will return a true. So now non-empty string. So this is true. So this also will be performed. Then or, okay, this happens to be true. Okay, this happens to be true. You have evaluated up to this point. You have already evaluated true. There is no point in evaluating um, the other parameter, or so it is going to return value 1 and not value 2. So what I'm trying to say is, instead of writing if and A and B, you can write it here like this, but be cautious. Not too many people, or not many people, know this convention, and they may get confused with your programming style. Okay, I am teaching you this, or actually highlighting it to you, because if you happen to see this, or your interviewer gives you this and then expects you to tell you the value of C, you should be able to say that it will be this and not a true or false, whatever it is. So, but don't write this code like this because it's not very obvious, like if and else. Okay, this is what you will get. Okay, this is another way of replacing that if and else with and or. Okay, I hope it's clear to you. What it returns, it returns the evaluation where it stopped, last evaluation, that object it returns. Okay, so it need not be always boolean. Okay. Okay, we are already crossed 7 o'clock, so I took liberty because I know there is no class and you have a break. I'm sorry. Okay.